Hi, Assalamualaikum students. We meet again. This is tutorial 03 and in this video I'm going to cover tutorial for chapter 2.1. Question number 1. Piston cylinder device contains 5 kg of refrigerant 134A at 800 kPa and 70 degrees C. The refrigerant is now cooled at constant pressure until it exists as a liquid at 15 degrees C. Determine the amount of heat loss in kilojoule. Show the process on a TV diagram with respect to the saturation lines. In this question, we have a piston cylinder contains a refrigerant initially at 800 kPa and 70 degrees C. Then the piston cylinder is cooled until the temperature drops to 15 degrees C. But this process happens at constant pressure, so the pressure will remain as 800 kPa. From the question, we need to find the Q out because of the temperature is dropping and heat will be released out. So Q is Q out. So from the first law of thermodynamics, we can find the Q. And for the other energy that is not involved, we can neglect out, which is delta PE, delta KE, and also W. So now, the first law of thermodynamics will be simplified into Q net in is equal to delta U. And this Q net in is equal to negative Q out is equal to delta U. And we know that the sign for Q that is removed from the system, we should put negative sign. And from the question, we have to realize that this process happens at constant pressure. Even though this is closed system, because of it is operated under constant pressure, so negative Q out can be related with delta H. We have to remember, this is for only constant pressure. So now, in order to find the Q out, we have to find the enthalpy for state 2 and enthalpy for state 1. At state 1, the pressure is 800 kPa and temperature is 70 degrees C. After we check from table A5, we have found that the phase for state 1 is superheated. And because of that, in order to find the H1, we have to find from table A13. And from table A13, H1 is equal to 306.88 kJ per kg. For state 2, the pressure is 800 kPa and the temperature is 15 degrees C, in which after we check with table A5, we have found that the phase for state 2 is compressed liquid. But for refrigerant, there is no compressed liquid table, so we have to go to table A11, in which at table A11, we have to refer to the given temperature, which is 15 degrees C, and we can find the H2. But in table A11, there are two H, which is HF and also HG. Because of state 2 is compressed liquid, we have to use the HF. So H2 is equal to HF, and HF at 15 degrees C is not available in the table. So that is why we need to do the interpolation. So this is how we do the interpolation. So we need to find the H2 at 15 degrees C. Thus, we need to find the H2 between the data for 14 degrees C and also 16 degrees C. So from here, we can find the H2 by using the interpolation. In order to do the interpolation, we have to do like this. H2 minus 70.95 over 73.73 minus 70.95 is equal to 15 minus 14 over 16 minus 14. Then we will get the H2 is equal to 72.34 kJ per kg. So now we have already found the H1 and also the H2. So we can substitute into this equation. So then we can find the Q out. After we substitute all the values, it will become like this. And it will give the answer of 1173 kJ. Next, question number 2. A 0.5 meter cube rigid tank contains refrigerant 134A initially at 160 kPa and 40% quality. Heat is now transferred to the refrigerant until the pressure reaches 700 kPa. Determine A. the mass of the refrigerant in kg in the tank, B. the amount of heat transferred in kilojoule, and C. show the process on a PV diagram with respect to saturation line. From the question, we have a rigid tank in which initially the pressure is 160 kPa and it is mentioned as well the quality, which is 0.4. When it is given quality, we know that the phase for state 1 is saturated mixture. Next, heat will be transferred until the pressure in rigid tank reach 700 kilopascal, which is in state 2. So first we need to find the mass. To find the mass, we can find by using this equation, volume over specific volume. But from the question, the only given is volume, so we need to find the specific volume. We know that in state 1, the phase is saturated mixture. So in order to find the specific volume, we have to use this equation. So the X is already given, which is 0.4, and by referring to table A12, we can find the VF and also VFG. So we refer at pressure 160 kilopascal, we find the VF and also VFG, we substitute in this equation, so it will become like this. Then we solve, then we get 0.04984 meter cube per kg. So from this value, we can substitute inside this M equation, then we can find the value for mass. We substitute and we get 0.5 over 0.04984, then we will get the answer of 10.03 kg. Next B, we need to find the amount of heat transferred. So in the question, it is mentioned that the heat transferred to the refrigerant in the rigid tank. So means that the Q is Q in. From the first law of thermodynamics, then we simplify until we get Q in is equal to delta U. Because of this is Q in, so the sign is positive. Then we expand this equation, we will get M multiplied with U2 minus U1. So means that we need to find the U at state 2 and U at state 1. First, we find U at state 1. Because of it is saturated mixture, we can use U1 is equal to UF plus X UFG. So from table A12, we will get the UF and also UFG. X is given, which is 0.4. Then after we substitute, we will get the answer 107.19 kJ per kg. Next, we find U for state 2. Before we can find the U2, we have to know first the phase for state 2. But now we have only one info, which is pressure. We need another info at least. Based on the question, the device used is rigid tank, and we know that the volume will not change. So because of that, V at state 2 is equal to V at state 1, in which it is equal to 0.04984 meter cube per kg. So by using these two info, we can find the phase for state 2. First, we go to table A12 and we find out that this V is over than the VG. So means that the phase is superheated. So next, because of it is superheated, we have to go to table A13. We just pick the value of U at pressure 700 kilopascal and we will get 376.99. So now we already have the value for U2 and also U1, so we can substitute into this equation. So Q in is equal to M, we have already found just now, which is 10.03. So U2 is 376.99 minus U1 107.19. Then after we solve, we will get 2707 kilojoule. So that's how we solve question number 2. Next, question number 3. A piston cylinder device contains 2 kg of saturated water vapor at 200 degrees C and 90% quality. The volume triples while the temperature is held constant. Calculate A, the heat must be transferred, and B, the final pressure. From the question we have a piston cylinder that is initially the temperature is 200 degrees C and it is given as well the quality. So if it is given the quality, means that the phase at state 1 is saturated mixture. Next, the volume of the piston cylinder is tripled. So means that the volume for state 2 is equal to 3 times the volume at state 1. Since the temperature is held constant, so temperature at state 2 is 200 degrees C. So first we need to find the heat transfer, which is Q in. According to the first law of thermodynamics, after we simplify, we will get Q in minus W out is equal to delta U. Because of heat is transferred into the piston cylinder, so the piston is moving, so means that the system is doing the work. When system is doing the work, means that the work is W out, so the sign is negative. After we rearrange, we will get W out plus delta U. So it means that we have to find the W out and also the delta U. So the W out we can find by using boundary work. Because of it is conducted in isothermal process, we can use the boundary work equation for isothermal, which is P1 V1 ln V2 over V1. Next, in order to find delta U, it is equal to M U2 minus U1. Means that because we are not given with V1, V2, U2 and also U1, so we have to find them first before we can solve what is Q in. In state 1, the temperature is 200 degrees C and it is given also the quality, which is 0.9, and because of we are given with quality, we know the phase is saturated mixture. So from this info we can find what is the V1, and for saturated mixture we can use this equation. By referring to table A4, at temperature 200 degrees C, we can find the VF and also VFG. So then we can substitute into this equation, then we will get the answer for V1 is equal to 0.1146 meter cube per kg. Next, for state 1, we have to find the U1, and the U1 also we can use this equation. By using table A4 as well, at temperature 200 degrees C, we can find the UF and also UFG, then we substitute into this equation, then we will get the answer for U1 is equal to 2419.8 kJ per kg. So now we have found the V1 and also U1. Next, we have to find the V2 and also U2. In state 2, we are given with temperature is equal to 200 degrees C and V2 is equal to 3 times volume at state 1, which is 3V1. We have already found the volume for state 1, so we can substitute in here, then we can get the volume for state 2, then we will get 0.3438 meter cube per kg. Next, we have to find the U2. Before we can find the U2, we have to find first the phase of state 2. So when we refer at table A4, and we have found that this V2 is over than VG, so the phase is superheated. Then we go to table A6, we need to find the U2 from there. But by using this V, when we find from table A6, it is not available. Means that we have to do the interpolation. By using the value of 0.3438 for V2, we can see that the 0.3438 is between 0.35212 and 0.26058. So means that the U is between 2639.4 and 2631.1. So from here, we solve this interpolation, then we get the U2 is equal to 2638.6 kJ per kg. So now from state 2, we have found the V2 and also the U2. Since we have found the V1 and also V2, we can substitute into this boundary work equation. Before we can start calculate, we have to find first what is P1, because P1 is not given in the question. So we look at state 1. Because of state 1, it is saturated mixture, so means that we can find the pressure 1 is equal to P saturated. So the P saturated from table A4 at temperature 200 degrees C, it is equal to 1554.9 kilopascal. So we can substitute into this equation. In this question as well, we can see here V1 and also V2, in which this V is volume, not specific volume. What we get in state 1 and also state 2 is specific volume. So we have to convert into volume first. So how? We need to multiply with the mass. Mass is given, which is 2 kg. So we can get the volume for state 1 and also volume for state 2. And V1 is 0.2292 kg and V2 is 0.6876. So then all of this value we can substitute inside this equation. Then after we calculate, we will get the boundary work is equal to 391.5 kJ. Then after we have found this value, we can substitute the value for work inside this equation. Other than that, we know already the value for U2 and also U1, so we can substitute them into this equation. So it will get like this. Then after we solve, we will get 829.1 kJ. B, we need to find the P2 or the final pressure. Because of in state 2, it is superheated, so we can find from table A6. By using temperature is equal to 200 degrees C, volume is equal to 0.3438, then we can find P2. But we need to do the interpolation first. By using V0.3438, we can find that the V is between 0.35212, which is at pressure 0.6, and 0.26058, which is at pressure 0.5. So it means that the final pressure is between 0.5 and 0.6. After we solve this interpolation, we will get the P2 is equal to 618.2 kilopascal. So that is how we solve question number 3. Next, question number 4. 200 grams of saturated liquid vapor at 150 degrees C is heated in a rigid tank until it exists as saturated vapor. Calculate the heat transfer required in this process in kilojoule per kg. From question, in a rigid tank, there is saturated liquid water at 150 degrees C and it is heated until it exists as saturated vapor. So we need to find the heat transfer into the system, which is Q in. By using first law of thermodynamics, we can cancel out W, KE and also PE, and Q net in is equal to Q in, and Q in is equal to delta U. So delta U is equal to M U2 minus U1. So it means that in order to find Q in, we have to find the U at state 2 and also U at state 1. If we can translate the question into TV diagram, we can see that at state 1 it is saturated liquid, in which saturated liquid is located on line of the saturation line, which is here, somewhere here, at 150 degrees C. And state 2, it is saturated vapor. From saturated liquid to saturated vapor, it will happen at constant temperature, or it will happen at T saturated. So it means that for saturated vapor, it should be here. So this is state 1 and this is state 2. So from this, we can see that the state 1 and also state 2 will happen at the same temperature, which is 150 degrees C. By referring at table A4, at temperature 150 degrees C, we can find the U, which is the U2 is saturated vapor, which is Ug at 150 degrees C, minus U1 at saturated 1 is saturated liquid, which is U1 is equal to Uf at 150 degrees C. So from table A4, we can find that the value for Ug is 2559.1 minus Uf 631.66 kilojoule per kg, and we solve, then we get 385.488 kilojoule. So this is how we solve question number 4. Question number 5. A piston cylinder device contains steam initially at 1 megapascal, 450 degrees C and 2.5 meter cube. Steam is allowed to cool at constant pressure until it first starts condensing. Determine A, the mass of steam, B, the final temperature, C, the amount of heat transfer, D, show the process on TV diagram with respect to saturation line. From the question, we have a piston cylinder device in which initially the pressure is 1 megapascal and temperature is 450 degrees C. So now the steam is cooled at constant pressure until it first starts condense. So state 1, we have steam which is superheated vapor. What does it mean is first start condensing is this superheated vapor will reach at point it can be condensed, means it is saturated vapor. For question A, we need to find the mass of steam. We can use this equation, which is volume over specific volume. So in order to find the specific volume for state 1, we can go straight to table A6 by referring to 1 megapascal and temperature 450 degrees C. From table A6, V is equal to 0.33045 meter cube per kg. By using this V, we can answer the mass. The volume given is 2.5 meter cube over V that we found just now. After we solve, we will get 7.565 kilogram. That is mass. Next, B, we need to find the final temperature, which is temperature at state 2. But from here, we already know that the phase is saturated vapor. Because of it is saturated vapor, we can just take the temperature 2 here is equal to T saturated. So it means that the T2 is T saturated at pressure 1 megapascal. It is equal to 179.9 degrees C. Next, question C, we have to find the heat transfer. According to the question, the steam is cooled down. So it means that this Q is Q out. From first law of thermodynamics, we can simplify into Q net in is equal to delta U, in which this Q net in is equal to negative Q out. But you have to remember that this system is undergoing the constant pressure process. So it means that we can replace with delta H. So in order to find the Q out, we have to find the enthalpy at state 2 and also enthalpy at state 1. For H1, we can find from table A6 at 1 megapascal and temperature 450 degrees C, and we can find that H1 is equal to 3371.3 kilojoule per kg. But for H2, we know that in state 2, the phase is saturated vapor, and because of it is saturated vapor, from table A5, we can find the H2 is equal to Hg. At 1 megapascal, the Hg is equal to 2777.1 kilojoule per kg. So now we have H2 and also H1. We can substitute into this equation. By using mass that we calculated just now, which is 7.565, H2 is 2777.1, H1 is 3371.3. After we solve, we will get 4495 kilojoule. Next, we have to show the process in TV diagram. At state 1, it is superheated vapor, so it is somewhere here. For state 2, it is saturated vapor and it should be on the line, and it should be lower than the state 1, because at state 1 it is 450 degrees C, and state 2 it is 179.9 degrees C. So this is how we show in TV diagram. Question number 6. A rigid 10-liter vessel initially contains a mixture of liquid water vapor at 100 degrees C with 12.3% quality. The mixture is then heated until its temperature 150 degrees C. Calculate the heat transfer required for this process and show the process on TV diagram with respect to saturation lines. From the question, because of the temperature is increasing from 100 degrees C to 150 degrees C, means that heat will be transferred into the system. So the heat that is required to be calculated is Q in. So from the first law of thermodynamics, we can neglect what is unnecessary, W, KE and also PE. So Q net in is equal to Q in. So Q in is equal to delta U. Delta U is equal to M U2 minus U1. So it means that we have to find the U2 and also the U1. In state 1, given to you is the temperature, which is 100 degrees C, and also the quality, which is 0.123. Because of the quality is given, we know that the state 1 is saturated mixture. Thus, in order to find the U, we can find from this equation, which is UF plus X UFG. From table A4, we can find the UF and also UFG at temperature 100 degrees C. So after we substitute into this equation, the UF and also UFG, then we solve, we will get, for state 2, the only info that is given is temperature, which is 150 degrees C. Because of the device used is only vessel or rigid tank, so it means that the volume at state 1 is equal to volume at state 2. So it means that the V2 is equal to V1. We want to find the U2. We should have at least 2 info, but here we have only 1 info, which is T. But the V, we need to find the V1 first before we can use to find the U2. So V1, because of it is saturated mixture, the V1 we can use this equation by referring at temperature 100 degrees C in table A4. So we can find the VF and also VFG. We substitute in here, then V1 we will get 0.2066 meter cube per kg. So from here, we know already what is V2. So before we can proceed to find what is U2, first we need to find what is the phase for state 2. By using V and also temperature, we can find what is the phase for state 2. By referring at table A4, we check at temperature 150 degrees C, and we look whether this V is between VF and VG or not. So after we have found that, this V2 is between VF and also VG. So that is why the phase for state 2 is saturated mixture. It is saturated mixture. We can find U2 is equal to UF plus X UFG. But before that, we need to find what is the quality or X. Because of we know already what is V, and V can find from this equation. So from this equation we can find the X. We rearrange the equation until we get this equation. So by referring at table A4 at temperature 150 degrees C, we can find what is VF and also what is VG. The V1 is 0.2066. After we substitute all the values, then we will get X is equal to 0.525. So by using this X, we substitute into this X, then we can get the value for U2. So U2, after we substitute all the values inside, UF and also UFG we get from table A4 at temperature 150 degrees C. So we substitute into this equation, then we will get the U2 is equal to 1643.5 kilojoule per kg. So now we have found already the U2 and also U1. Then we can substitute into this equation, but before that we have to find the M first. So how to find the M? Because we are given with volume, which is 0.1 meter cube. So by using this V1, we can find the M. So M, we will get 0.04841 kilogram. Then we can substitute into here, and also U2 and also U1 we can substitute into this equation. Then we will get the answer 46.9 kilojoule. So that's how we solve question number 6. So we have finished this tutorial. I hope you understand, and if you have any question, you can directly contact me. Till we meet again in the next video. Thank you and Assalamualaikum.